Hi, this is Hilal. In this video on Mathematical Economics series, we will solve a numerical on finding the profit maximizing level of output and prices, and also finding the price elasticity of demand for a monopolist. The question is, a monopolist faces the demand curve that is Q is equal to 120 minus P by 3, where Q is the quantity and P is the price. Also, the cost function is given as that is C is equal to Q cube. Find the output and the prices that maximizes monopolist's profits. So we have to find the output and price that maximizes its profits. Also, we have to find the maximum profit at that level of output, and subsequently we have to find the elasticity of demand at profit maximizing level of output. Okay, so the question has too many parts, so we will try to figure it out. First of all, we will see what is given. We are given a demand curve. Let us say this is Q is equal to 120 minus P by 3. Also, cost function is given is that is C is equal to Q cube. Okay, first, as we know that the condition for profit maximization is, that is the first order condition for profit maximization is, so I will write first order condition for profit maximization. I will write profit maximization is that marginal revenue should be equal to marginal cost. Okay, this is the first order condition for profit maximization. Okay, so what we have to find out first, we have to find out the marginal revenue and marginal cost, but we are given only the demand curve and total cost. Okay, first of all, what will we do? We will this is our demand function, and we will find the inverse demand function first. We will solve this demand function for price. Okay, so this is simply, we can write if we transpose this P by 3 on LHS, this will become plus P by 3. So this is P by 3 is equal to, this is 120, and we will transpose this Q on RHS, this will become negative Q. Okay, which implies we can write P is equal to, now this 3 will be multiplied to both the terms on RHS, so 3 into 120 is equal to 3 zeros are 0, 3 twos are 6, and 3 ones are 3, minus 3 into Q is 3Q. Okay, this is our inverse demand function. Okay, inverse demand function. To find the marginal revenue, first we have to find what is the total revenue. Okay, we can now calculate the total revenue. As we know, total revenue is simply equal to price times quantity. Okay, now we have this inverse demand function, which is in the which is explicit in Q. So here we have in place of P, we have this very function. So in place of P, I can write 360 minus 3Q. So I will write 360 minus 3Q. Okay, and it is multiplied by Q. So I will multiply it by Q. This will give us the total revenue in this case. So our total revenue would be equal to, now 360 times Q is equal to 360 Q. Okay, minus 3, we have 3, now Q into Q is equal to Q square. Okay, so we got the total revenue here, total revenue function. Now we can easily calculate the marginal revenue. Marginal revenue is nothing, it is the first derivative of the total revenue with respect to quantity. So I will write marginal revenue is simply equal to the derivative of total revenue, okay, with respect to quantity. Okay, that means we have to differentiate this very function with respect to quantity. The derivative of Q in this 360Q is simply 1. By power function rule, this Q will become 1. The derivative of Q would be 1. So this is 360. In place of Q we have 1. 360 into 1 is 360, minus, simply now here we have 3. Now the derivative of Q square is simply 2Q. This 2 becomes the coefficient, so this becomes 3 into 2 we have q, and the exponent is subtracted by 1 by the power function rule. So I will write here 2 minus 1. Okay, so our marginal revenue is simply 360 minus 3 twos are 6q. Now 2 minus 1 is 2. We don't write actually the power 1. Okay, this is our marginal revenue. Next step would be to find the marginal cost. So it is very easy to calculate because total cost is given. Now C is equal to Q cube, that is the total cost. Sorry, it is Q cube. From that we can find the marginal cost. Marginal cost is the derivative of the total cost with respect to a quantity. So D C divided by D Q. Okay. Now total cost is this q cube. The derivative of q cube is simply, as I have told you, the power function rule tells us the exponent becomes the coefficient. So this 3 will become the coefficient times q, and this exponent is subtracted by 1. Okay, so our, sorry, it is marginal cost here. I wrote it marginal revenue. So that means our marginal cost is equal to 3q. Now 3 minus 1 is 2. So 3q square. Okay. I hope I am making myself clear. Now what we have to do, we have to equate these two because the first order condition requires marginal revenue should be equal to marginal cost. Okay, now equating these two, now that means marginal revenue is equal to marginal cost, implies our marginal revenue is we have calculated, this is our marginal revenue, that is 360 minus 6q should be equal to the marginal cost, that is 3q square. Okay, now solving this is 3q square, so I will write here 3q square. Now transposing this on LH RHS, this will become positive 6q minus 360, which is equal to 0. Okay, now we can factor out 3 here. So this is 3 q square plus 3 twos are 6. So here it is 2q minus, simply here we have 3 ones are 3, 3 twos are 6, 3 zeros are 0, which is equal to 0, or q square plus 2q minus 120 is equal to, now this 3 when transposing to RHS, this will become 0 divided by 3, which is equal to 0. Okay, so we are encountered here with a quadratic equation, and we can solve this quadratic equation. Okay, so how do we solve uh, the quadratic equation when given in a standard form? How do we find the zeros of this quadratic equation? The simple rule is that the sum of the two numbers should be equal to the coefficient of the middle term. That is, we should get two numbers such that their sum should be equal to 0, and simultaneously the product of the two numbers should be equal to the constant term, that is minus 120. Okay, so that means we have to find the two numbers such that their sum is equal to 2 and also their product is minus 120. Okay, so we can take 120. We have 120 here. So if we take 10 and 12, so if I write here, let us say we have 12 and minus 10, 12 and 10. Okay, 12 and minus 10, this will give us 12, and 12 minus 10 is equal to 2, and also 12 into minus 10 is equal to minus 120. Okay, so I can write here q square plus, in place of 2q I will write 12q minus 10q. So I will write 12q minus 10q. Okay, minus, in place of 120 I can write 12 and minus 10. That is, I can write 12 into minus 10. Okay, which should be equal to 0. Okay, here it is positive. Now we have to factor this out. From here we can see q and q will get factored. So q, when factored out, we will get here q plus 12. Here if we factor out minus 10, we can factor out minus 10 here. Okay, so minus 10 when factored out, we will get q plus 12, which is equal to 0. Now q plus 12, we will factor this out again. Q plus 12, when factored out, we are left with q minus 10 should be equal to 0. That implies either q plus 12 is equal to 0 or q minus 10 is equal to 0. If q plus 12 is equal to 0, that implies q is equal to minus 12 here also. Or if q minus 10 is equal to 0, that means q is equal to, when transposing, this will become positive 10. Okay, but as we know, quantity cannot be negative. Quantity can't be negative, so we will not take this number. Okay, because we got here negative number. That implies profit maximizing quantity would be equal to 10. Okay, I hope I make myself clear up to this. Now what will we do? We got the profit maximizing quantity. Okay, also we will find the profit maximizing price, because the question tells us to find the profit maximizing price also. So if q is equal to 10, we can simply find the profit maximizing price. That is, we will put q is equal to 10 in this equation, in this inverse demand function. So we will put, let us say this is equation first, whatever you call it. So put q is equal to 10, q is equal to 10 in equation first. So that implies p is equal to, we have 360. I will write 360 minus 3. Q, the value of q is 10, so I will write here 10. So we will get here 360 minus 3 tens are 30, which implies we got 330 as the profit maximizing price. That is, 330 is the profit maximizing price. Q is the profit maximizing output. Okay, this was the first order condition. Also, the second order condition for profit maximization requires that. So I will write, should I rub this? Okay, I will rub this. I will rub this out. Let me rub this. So second order condition for profit maximization requires for profit maximization requires that the slope of, that is, slope of marginal revenue should be, that is, the slope of marginal revenue at the intersection of the marginal revenue and marginal cost should be less than the slope of marginal cost. Okay, that means slope of marginal revenue means the derivative of marginal revenue, that is dmr divided by dq should be less than d marginal cost divided by dq. Okay, so our marginal revenue function is this. Uh, we have to what we say, we have to differentiate it with respect to quantity. Okay, again, so 3 2s are is 6, so we will get here 6. So I will write here, sorry, our marginal revenue function is given somewhere. This is our marginal revenue function. The derivative of this marginal revenue function with respect to quantity is simply the derivative of constant is 0. Here the derivative of q is 1, so we will get minus 6 into 1 minus 6, so we will get minus 6. Now the slope of marginal cost, this is our marginal cost curve. Its slope would be, we differentiate again with respect to quantity, so this 2 will become the coefficient, so this is 2 3s are 6, we will get 6q. And here we can easily see that 6q is greater than negative 6. That means second order condition is also satisfied. Okay, so we can write second order condition is also satisfied. Okay, now so I will rub this out. The question tells us further to find the maximum profit, so we will find the maximum profit also. So maximum profit is simply profit is equal to total revenue minus total cost. Okay, now total revenue, as we know, is equal to price times quantity minus total cost is given as somewhere we are given that is q cube, so I will write q cube. Okay, now profit when q is equal to 10 would be equal to, now price is given as 330, I can write 330 times 10 minus q is 10 cube. Okay, so this is 330 into 10, we have 2 zeros here and 3 so we will get 3300 minus, now 10 cube is 1 and we have 3 zeros, so we have 3300 minus 1000, which is equal to 2300. So maximum profit would be 2300. Okay, I hope I am making myself clear. Similarly, we can find I am really sorry for the background noise. I cannot control that very variable here. So next, the question tells us to find the elasticity of demand at profit maximizing output. So the last part of this question is to find the elasticity of demand. Okay, so what will we do? We will rub this very thing. I will rub this out, so we got the profit also. Now elasticity of demand is simply equal to elasticity of demand. The formula for elasticity of demand is simply, that is dq divided by dp times p by q. Okay, that is elasticity of demand is equal to this. Okay, now dq divided by dp, that means we have to differentiate this demand function with respect to price. Okay, the derivative of constant is 0, the derivative of p is 1, so we will get minus 1 by 3 as dq divided by dp, so this is minus 1 divided by 3 is our uh, dq divided by dp times our p is equal to, we have calculated p is equal to somewhere, p is 330 divided by quantity is 10. Okay, so we can take this and cancel the zeros, so we will get here minus 33 divided by 3, so this is minus 11. And we always take the absolute value of the price, elasticity of demand, because of the inverse relationship between price and quantity. So elasticity of demand would be equal to minus 11, the absolute value would be equal to 11. Okay, so we just ignore the sign. So we got the elasticity of demand is 11, which means the given demand function is elastic in nature. That means if price increases by 1%, okay, that would mean quantity demanded would decrease by 11%. Or if price decreases by 1%, quantity demanded will increase by 11%. Okay, I hope I make myself clear in this video. If you like these videos, please share, subscribe. Thank you.